Okay, guys, we're on page 12. We're going to talk a little bit more about three-dimensional solids and shapes right here, and some of the just the different things that happen, different ways to form these actually. Okay, so I'll just show you a few visuals right here, which I think are going to be pretty helpful for you to figure out what this is talking about right here. It says the math club at school is planning on a pancake breakfast as a fundraiser. The pancakes will be various geometric shapes, so we're going to have a little creativity here. Okay, so if you can imagine stacking all of these circular pancakes, if we had a perfect way to pour pancakes and make them all congruent and they were the exact same circle over and over again, and of course, if we stacked these higher and higher and higher, we would get a visual that looks like this. Okay, so hopefully this isn't making you too hungry, but a really really tall stack of circles forms a cylinder, obviously. So this is kind of where we're going with this. What's the name of the solid formed? It would be a cylinder. All right. Relate the dimensions of a single pancake to the dimensions of the solid. I guess, one of the main things would be that this radius right here would be consistent all the way throughout. So radius consistent from bottom to top. Right? Imagine that we could pour some square pancakes. So you can imagine what's going to go on right here. I know this is probably impossible to pour really a square pancake, but we're using some imagination here. So if I stacked multiple squares on top of each other, it really depends on how high I stack this. So maybe the first thing you're thinking of is this would form a cube, which it might form a perfect cube, that looks where all of these dimensions are the same. Like you have used this before, like the length, the width, and the height are all the same. But if I continued to stack these higher and higher and higher, to where not all the dimensions are the same, where the length and the width are different than the height over here, then we're not going to call that a cube anymore. So the safe term to use here and that we communicate, I think we've already established this, is that squares are also considered rectangles. So we call these rectangular prisms. Okay, prisms, remember, have an identical top and bottom. So the top and bottom are identical. Right here, the top and bottom are identical. Okay, relate to the dimensions of a single square to the dimensions of this solid. We could say it's the same, or the same. They're consistent throughout, or the same throughout. This length and width, what we're getting at right here, this length and width is the same length and width up here. This would still be the length, and that'd be the width. All right, they're all the way through, same throughout. Okay. What if we could stack some congruent triangles? So let's just, draw this as best we can right here. We'll put a triangle here and here. And so what's happening is, use a dotted line back here. Okay, some of these kind of become artistic. You do need to learn how to draw in some 3D. So if you can think of it inside here of this triangle being stacked consistently all the way through, this is still a prism because it has the same base on top and bottom. So we would name this a triangular prism. What do you notice about the three-dimensional solids? All of these solids formed by creating stacking figures. They have two bases. All right. One of the things that gets a little bit, difficult for students to understand is that what if we had a diagram that looked like this and we stacked it this way? What do we consider the bases right here? We're gonna talk about this again here in a minute, but these two are what is being stacked consistently all the way through here. So that's the stacking. So we really still call this a triangular prism. It's stacked horizontally, and these two end pieces are the two bases. All right. So this is a big deal that all of these prisms and cylinders have two bases. What type of solid will be formed by stacking congruent rectangles? We already went over this. So any of these things that we say, we would just name them for example, a hexagonal prism. Let's put the word prism at the end of it. So again, you'll draw them kind of skinny. It kind of helps you sketch one of these out and then just connect all the sides like this. And you can kind of start to build your prisms that way. Okay, so another idea here is that what if we don't stack congruent shapes? Like we said, we poured all these triangular pancakes the same and we stacked them. By the way, I think I have a few visuals here for you stacking like this, stacking all these rectangles right here on top of each other. All right, little thin pieces of rectangles, stacking some squares like this one, or books or whatever you want to think. They're all stacked in there. Okay. So that's stacking congruent figures, but let's talk about stacking similar figures. Similar meaning each one has been dilated, and it says we're going to pour these pancakes so that each layer is slightly smaller. All right. So that means I would have a pancake on the bottom, and then I would have another one right here that's a little bit smaller, and another circle a little bit smaller, a little bit smaller, a little bit smaller. Okay, you can imagine what we're getting to right here if I stacked all these. All right, that's a pretty bad picture there. Sorry. Anyway, each stack got slightly smaller, a smaller dilation of the previous one. Okay, because remember, that's what similar means. These, I think we all would remember the word is cone. All right. Relate the dimensions of a single pancake. So I would say on this one that the radius changes. Okay. The radius changes as we stack. It's not consistent all the way throughout. If we did stack similar square pancakes on top of each other, what we're going to get into is drawing a pyramid, just like, the pyramids of Egypt that you've always, you can picture in your mind. It's a little bit artistic in drawing these. Instead of drawing a square, we have to draw these with a three-dimensional view. So what works is to draw a parallelogram for the base and then pick a point up here. And then from there, you will draw in all of these. You might put a dotted line back there or something like that. So it appears to have some 3D perspective to it. And we would still be told this would either be a rectangular prism or pyramid. I'm sorry, a rectangular pyramid. Like if this down here was a rectangle, these are still. That means you would have to see that those were all right angles down there. Okay, or a square pyramid. All right, rectangular or square depends on the problem. Okay. Most of the time, we would call this a rectangular if we don't know for sure that thing is a square. All right. If I did triangles the same way, okay, what's the name formed? Triangular pyramid. All right. what do we notice about stacking similar figures? There is only one base. These only have one base. And of course, we could even have a pentagonal. If I wanted to try and draw 1, 2, 3, 4, 5, pentagonal pyramid. All right. Pick a point up here, connect all the lines. Something like that. All right. What type of solid is formed? They're all pyramids. Okay. The only other thing we might add to this, there's another term in here that they only have one base. Also, this point up here is also something we refer to every now and then. This one is the apex of all these pyramids and cones. Okay. So let's talk about, we kind of started doing a little bit over here about height. All right. So this is more of a bigger idea that we're really needing to develop and make sure we're all on the same page here about height, because this is when we're going to start doing some of our volume. This becomes key about how we're going to calculate volume. And so that's why we're experimenting with all these shapes to get us ready to do all these measurements like area, volume. All right. So this word has quite a few meanings to it now. So it's not just, you can't just assign height anywhere. Okay. So how do we describe and communicate their height? So I'm going to label these, and I would challenge you to pause your video now and try and draw these because we're going to label the heights. So I would say, if this triangle was stacked all the way up, the distance that we stack this from here to here would be considered the height. How far did we stack it? 8 inches, whatever. Okay. And that's pretty easy to see on a lot of these. This is be the height. Okay. This one right here, this has a rectangle on the bottom. This would be its height. Now, I will say this while we're on this rectangular prism, it's kind of an anomaly. The rectangular one is the only one that works this way. Someone could argue that this side was the base and it was stacked all the way through to this side. And so technically, we could argue that this side over here is the height because it was stacked this way. So we will get into that more. I will show you why that happens and how we use that. But the height on the rectangular prism can sometimes be argued whether it's out here or it's over here. Like we could probably argue that this right here is the height. Okay, and I know in your mind you're just wanting the thing to be sitting on the ground and stacked up. We have to get away from that a little bit. For example, if I take this cylinder and I knock it over, where's the height? Well, the height, remember, is the distance between the two bases. Maybe we should say that. Distance between bases. So if this is a base and this is a base, then my height is right here. It's running in between those. That's how we're going to define that and measure that. It's not going to be this, because technically that right there would just be the diameter of that circle. And we'll deal with that as a separate measurement. That's not the height of the cylinder. You'll hear me emphasize the prepositional phrases. You can't just say height. You have to say of what? Of the cylinder. The height of a triangle. We're going to get into all those. You have to follow up with what you're talking about. Now let's talk about the pyramids, the cones, the height. Technically, since we wrote distance between the bases, actually it's going to be the distance between the base and the apex now. So your height is going to be on the interior. So I want you to try and draw these and sketch these in, especially these right here. So this one's height is running somewhere right in here to the center of this. That's where that height is. Okay, this one's height would be running in here. All right, this is your height, even though the cone is knocked over. Let me show you a couple of demonstrations here about height. And you can Google this and see this anywhere. So here's a pretty good example of a square pyramid or a rectangular pyramid. The height is right here, and we are going to start using this term eventually. That this out here is the slant height. Those are different. Okay. And you can see some pictures in here where they formed a triangle. This right here would be the height. This out here would be the slant height. There may be some other good pictures in here. Here's one that's decent. The altitude, okay, there's a word for us, altitude, and it says in parentheses height. All right, and then this out here is the slant height, and there's the word apex there. Okay, let's talk about the height of a cone. Again, height and slant height. There they are, height and slant height. Okay, this one had a little demonstration over here that was pretty good. Here's the altitude or height, slant height out here, and then there's a radius. So you can start to see on a lot of these, what forms in here is a triangle. And this one, I'm adjusting the height and slant height and the triangle. And we could do, and this is, a little prelude of things to come. What's going on right here? What does this look like to you? You should recognize this. If we have this number and we can find the slant height, we're going to go back and use some Pythagorean theorem. Okay. But you will always mess up your stuff if you don't know where the height is. And so that's kind of our focus right now of identifying the height and how we communicate that on these solids.